Okay, so let's have a look here at these exercises. So this is problem 2 on the handout that we have here. As an exercise, verify that the shoelace theorem works for a parallelogram, one vertex at the origin, one of its sides lying along the x-axis. Okay, so as always, we'll sketch it out here. So we're going to create our parallelogram next. So this vertex is going to be 0, 0, and then it's going to be somewhere over here. There's going to be a, 0 here, and then we're going to have our parallelogram look something like this here. Okay, there we are. Now, in this case here, this point, we're going to call this here. Now, this point, we don't know what that is. I'm going to call it B, C. Now, note that in this situation here, it shouldn't be too hard to show what's going on. Note that the y-coordinate here is going to be C because it's parallel to the other side here, and this side is indeed horizontal. Now, to figure out what this is, we know that this is A units away from 0, so then it's going to be A units away from B. This is therefore going to be A plus B. Okay? So now we're going to go ahead and set this up here. So yet again, we're going to start off with any point, and we're going to go in any order around. We're going to go in either clockwise or counterclockwise order, and make sure that we go back to 0, 0. So we start with 0, 0 here. In this case here, then A, 0, then A plus B, C, then B, C, and then finally 0, 0. So the area of this object here, again, the area of a parallelogram is base times height. The base is length A, and the height is length C. So we want there to be an AC at the end here, right? The base is A here, and the height is basically how high this is off the x-axis, and that's going to be C. All right, so let's go ahead and do this here. All right, let's see. 0, AC. Now I'm going to write this as, I'm actually going to do the distribution now. A plus B times C is AC plus BC here. And this is going to be 0. So the nice part, again, note that by putting zeros here, we actually make a lot of the product 0, and that makes things easier to calculate. This is 0, 0, BC, 0. So this is a good thing here. We can see what's going on. So now in this situation, we can sum these up. This is going to be BC here, and this here is going to be, let's see, I see 2 copies of AC and a BC here. So the area is going to be 1/2 the difference between the quantities here. So this is clearly the bigger quantity because A, B, and C are all positive here. So I can write this as 2AC plus BC minus BC here. These vanish, and we're left with 1/2 of 2AC, which is indeed AC here. And you can see that this does actually work for the parallelogram. Okay, now, number 4. Suppose that a quadrilateral has these vertices here, and A and B are integers where A is B is bigger than 0. PQRS is an area of 16, compute A plus B. So there are a couple ways you can tackle this problem. You can see what's going on in this situation here. Now, one thing is that we have all the vertices here, so let's use shoelace since we already know it. So we have AB, BA, minus B, minus B, minus A, and then finally back to P, which is AB. So we're going to go ahead again and just calculate this out. Let's see. A squared minus B squared. Minus A times minus A is a positive A squared, and a minus B times a positive B is a minus B squared. And we do the same thing on the other side here. B times B is B squared. This is a minus A squared. This is negative B times negative B is a positive B squared. And we have A times negative A, which is a minus A squared. So we can see that it actually works out pretty well. So in this situation here, we have 2A squared minus 2B squared. And this here is going to be 2B squared minus 2A squared. Note that A is bigger than B is bigger than 0, so that means this is the positive quantity here. This is going to be bigger. There's going to be a positive quantity. This is going to be a negative quantity here. So that means I'm going to have the area here being 1/2 the difference between the two. So it's going to be 2A squared minus 2B squared minus, parentheses, 2B squared minus 2A squared. Okay? That's 1/2 of, let's see, 2A squared minus 2B squared minus 2B squared plus 2A squared. So we can see that we actually have 2 copies of everything. That's going to be 1/2 of 4A squared minus 4B squared. And then in this situation, we can see that that's going to be 2A squared minus 2B squared. So we found that the area of this object, this quadrilateral here, is 2A squared minus 2B squared. And we're told that it has an area of 16. Therefore, A squared minus B squared is 8. Now, in this situation here, we can see that A and B are integers with AB is greater than 0 here. This means that there are 2 integers whose squares have a difference of 8 here. And you can do this by inspection or do some algebra here and prove to yourself that in this situation, there's only one thing that can work here, right? So if we have A plus B times A minus B, equals 8. This is either 8 and 1 or 4 and 2 here. Note that we can't have any negative quantities here because that would imply A or B is negative, which is not true. Now, if we try putting 8 and 1 here, this is not going to work, because if you put 8 here and 1 here, you're going to get that A and B are not integers. In fact, I think there's actually going to be 3.5 and 4.5. So that doesn't work out. So therefore, let's let this be 4 and 2. We get A plus B is 4, and A minus B is 2, and we see that this indeed works. This yields us A equals 3 and B equals 1 here. So that means A plus B is 4, which is what we wanted. Okay? Now, alternately, another thing you can do here is you can, because these only have specific variables, only A, B, E here, you can actually do this by inspection here. You can find the slopes of this. You should be able to suspect that this quadrilateral is a rectangle, and I think you can actually prove this using slopes here. But I'm going to leave that as an exercise to you. Okay? Now, number 5. Number 5 here is a bit of a challenging problem here. So we're told that we have a quadrilateral ABC that has these properties here. We want to put this all together. So let's go ahead and sketch this out. As always, we want to sketch out a picture of what's going on here. I have a bit of a big picture, but that's okay. And then we'll do the calculations beneath. So here's A at 0, 0. B is going to be at the point 1, 2. C is going to be at the point 3, 3. And D is going to be at the point 4, 0. Alrighty, so we're going to go ahead and sketch this out here. So ABCD, as you can see, is some sort of irregular quadrilateral here. We're told that ABCD is divided into 2 polygons with equal area by a line that passes through A. So that means there's going to be a line that passes through A that runs through here. Now, it's pretty clear that if it's going to pass through this quadrilateral and split it in half, it has to either hit BC or AD or CD here. But we're not exactly sure which. I think the first thing we note here is that since we have equal areas, we might as well calculate what these areas are. So let's do that. Let's calculate the area of ABCD, and here we can note that we can use our, you can use the shoelace formula or whatever other methods that you have here. Let's shoelace this. So again, 0, 0, 1, 2, 3, 3, 4, 0, and back to 0, 0. So we're going to go ahead and do this here. So let's see, that is 0, 3, 0, 0. So again, note the advantages of a bunch of zeros. This is a 0 here, 2 times 3 is 6, 3 times 4 is 12, and 0, 0 here. So we have a sum of 18 here and a sum of 3 here. So the area is 1/2 of 18 minus 3, which is 15 over 2. So the area of ABCD is 15 over 2. So let's call E the point where it hits, where this line hits one of these sides. So that means it's going to be 15. That means the area is going to be, the area of each half is 15 over 4. However, one thing you may note here is that if it tries to go through BC, if we look at triangle ACD, that's a triangle with base 4 and height 3. And the area of that is 1/2 times 4 times 3 or 6. Now 6, if I'm not mistaken here, 15 over, so, sorry, I think I screwed up here, I apologize. 1/2 times 4 times 3, yeah, is 6. Now, note that the area of our triangle that we want, the area of the figure that we want is 15 over 4, and 15 over 4 is significantly less than 6, which means that I can't have the figure go through BC, because then, as you can see, if we have it intersect anywhere over here, we're going to get something bigger than this triangle, and that triangle's area is 6. Therefore, our triangle here, our line here, is actually going to hit somewhere like this here. It's going to slide through CD here, and I'm going to call this point here E. I don't know what it is, but that's okay. We have to determine the coordinates of it anyway. And in this situation here, we have the fact that AED has an area of 15 over 4. Now, luckily, that's actually not hard to calculate here, because we can see this is a triangle with a base that is horizontal, and we know the base is 4, so that means the height, so that means we can now calculate what the height is here, right? So this is going to be our height. So therefore, that's equal to 1/2 times 4 times h, and that's 15 over 4 here. So half of 4 is 2, so you have 15 over 4 equals 2h, so h is therefore 15 over 8. That's a useful piece of information, because now that tells us that the y-coordinate of point E is 15 over 8. Now I just have to figure out the x-coordinate. So we basically have taken care of this business here. We've talked about this, and we now know that this is 15 over 8. So this point here, whatever this point is here, this point, let's call it Q. Q, 15 over 8 lies on this line, which doesn't help us much, but it also lies on this line here. It lies on CD. So we can try to find the equation of CD here and use that to figure out Q. So let's look at CD here. So CD here, again, we see that the slope is going to be 3 minus 0 over 3 minus 4, which is 3 over negative 1, and that's a minus 3 here, so that's CD. So therefore, we can use, I'm going to use point slope form here because I have 4, 0. So it's y minus y1 equals m times x minus x1. Y minus 0 equals negative 3 times x minus 4. So that tells us here that y equals negative 3x plus 12. And I think you can show here that every point, 4, 0 satisfies the equation, so does 3, 3. And now, the most important part is so does q comma 15 over 8. So now let's go ahead and substitute this in. So y, we know y is 15 over 8, so I'm going to plug that in here, 15 over 8. That's equal to negative 3q plus 12, right? Because that is the point that we had here, so we can solve for q now. So let's see here. Let's see, that's 15 over 8 minus 12 equals negative 3q here. 12 is 96 over 8, so it's 96 minus 15, which is 81. And that's a minus 81 over 8 equals minus 3q here. So I can divide both sides by negative 3. That's really multiplying by negative 1/3 on both sides here. So in this situation, that becomes, let's see, q is, 3 goes into 81 27 times. So that's 27 over 8, and that's a positive value here. So q is 27 over 8, and we know that there are no common factors here. So that means this point is 27 over 8 comma 15 over 8. The problem asked, what is the sum of all of the things here, okay? Right? Because it says to write it as a fraction. So therefore, we can now add everything together. 27 plus 8 plus 15 plus 8. Let's see, that is 35 and 15 is 50 plus 8. And that yields us, oh, I'm sorry, I forgot the calculations here. And that yields us 58.